All right, let's talk about two classic developer headaches. Have you ever, say, pushed a commit to your company's repo using your personal GitHub account by mistake? Or maybe you've watched your app just freeze while it's waiting for some data to load? These are two totally different problems, but they have one thing in common. They are super frustrating. And today, we're going to solve them both.
Oh man, we've all felt that little jolt of panic, right? You push a commit, you look up, and there it is, right on the company's main branch. Your personal avatar, your personal username. It just looks messy, it's a little bit embarrassing, and the good news is it's completely avoidable.
And then there's the other big headache, the one that drives your users crazy. Your application just feels sluggish, the UI is completely frozen, and it's all because your code is stuck, just sitting there, waiting for one single task to finish up. It's a classic performance bottleneck, and it is the second big problem we're going to solve today. Okay, so first things first, let's get your identities sorted out. We're going to build a totally clean, bulletproof SSH setup that lets you switch between your work and personal GitHub accounts without even thinking about it. Seriously, the goal here is to set it up once and then just forget it even exists. It's a really simple four-step process. First, we're going to generate a unique SSH key for each account. Then we'll tell our system about them, authorize them over on GitHub, and finally, we'll create one tiny configuration file that does all the magic for us.
So step one, let's generate the key for your company account. We're going to use the ssh-keygen command, and I highly recommend using a modern secure algorithm like Edge 25519. Now, the two most important parts here are the -c flag, that's where you'll pop in your work email, and then the file name you give it when prompted. Using a really specific name like id_ed255_company is going to be key to keeping things organized.
And then, you guessed it, we do the exact same thing for our personal account. Same command, but this time, of course, use your personal email as the comment and save the file with a different name. Something obvious like id_ed25519 personal. And just like that, you have two distinct, super secure keys sitting in your .ssh directory. Next up, we need to introduce these new keys to the SSH agent. You can think of the agent as a little background helper that securely manages your keys for you. Running ssh-add for each key basically loads them up so they're ready to go for authentication without you having to type in your passphrase every single time. It's a huge time saver. Okay, time to tell GitHub that these keys exist. You're going to use the cat command to display your public key. Now, this is super important. Make sure it's the file ending in .pub. You copy that whole block of text, then just head over to your work GitHub account settings, find SSH and GPG keys, and paste it in. Then you just rinse and repeat for your personal account with your personal key. And now this is the magic. This is the secret recipe that ties it all together, the config file in your .ssh folder. We're creating a custom host alias for each account. Think of github-company as a special nickname. When SSH sees that nickname, this config file acts like a little instruction manual, telling it to connect to the real github.com, but only using the specific company key we made earlier. It's so simple, but so powerful. And here it is, the payoff for all that setup. From now on, whenever you clone a repository, you just use your custom host alias. So git at github-company for work stuff, and git at github-personal for all your side projects. Git will now automatically use the correct SSH key, which means the correct GitHub identity gets used every single time. No more mix-ups, problem solved, for good. Okay, one problem down, one to go. With our workflow all cleaned up, let's go tackle our second challenge, performance. Because, just like a messy commit history can cause friction for you, slow and unresponsive code can absolutely ruin a user's experience. And the root of this problem is often something called the synchronous bottleneck. Synchronous code is how we all learn to program, right? It's simple. You write a line, it runs. You write the next line, it runs after the first one is done. It's totally predictable. But what happens when one of those lines is something like, go fetch 10 megabytes of data from a really slow server? Well, the entire application just stops, and it waits. The best analogy I've ever heard is a highway. Synchronous code is like a single-lane road. If one slow tractor gets on, everybody behind it is stuck. Asynchronous code, on the other hand, is a multi-lane freeway. That slow task can just move over into its own lane, while the main flow of traffic, which is your application's UI, keeps zooming along smoothly. This is the absolute core of a responsive app. So you might be wondering, how does this actually work under the hood? Well, in JavaScript environments like a browser or Node.js,
There's this process that's always running called the event loop. You can think of it like an amazing air traffic controller for your code. When it sees a slow task, like a network request, it hands it off to be worked on in the background. It doesn't wait around. It immediately moves on to the next thing, keeping your app from freezing. Then, once that slow task is finally finished, the event loop gets notified and brings the result back into your main code. Now, for years, developers had to manage all this async behavior with a pretty messy pattern called callbacks. But thankfully, modern JavaScript gives us a much cleaner, way more powerful tool for handling these future results: promises. That old callback-based approach was just notoriously difficult to read. You'd end up with functions nested inside other functions, nested inside other functions, creating this pyramid of code that developers famously called callback hell. It was a nightmare to debug. Promises were designed specifically to get rid of that pyramid and make async code logical and readable again.
So what exactly is a promise? Well, the name is actually perfect. It's an object that promises to give you a value back, eventually. When you kick off some slow operation, you immediately get a promise object back. It's basically a placeholder, like an IOU from your code. It's a ticket you can check later to see if your data has finally arrived or if something went wrong along the way. And every single promise can only be in one of three states. It starts as pending, it's just waiting. If the operation succeeds, it transitions to fulfilled, success, you get your value. And if something goes wrong, like the network fails, it becomes rejected, and you get an error instead. This simple, clear lifecycle makes handling asynchronous code so much easier to manage. So let's just step back for a second. We've tackled two really different problems, right? One was all about our personal workflow, and the other was about our code's performance. But you know what? They both lead to the exact same place. Mastering tools just like these is what separates OK code from truly professional-grade code. So here's the bottom line. First, a clean SSH config protects your professional identity and keeps your contribution history neat and tidy. Second, a solid grasp of promises lets you build the kind of fast, modern applications that users just expect these days. These aren't just little tricks. They are absolutely fundamental skills for writing high-quality, professional code. Look, you've just figured out how to solve identity chaos and performance bottlenecks. You have eliminated two major sources of friction from your daily work. So the question I want to leave you with is this. Now that your commits are clean and your code is fast, what's the next inefficiency in your workflow that you're going to conquer? What's the next small improvement you can make that will have a huge impact?